Hello, everyone. Me and my colleague Daniela Rocho Martinez Wepes will present the topic Response Animation Idle Load, the Rail module. Next slide, please. So, here we can see the table of contents. We will start by a short introduction and then we will continue talking in more detail about the response animation idle load. Nextly, we will talk about the time and perceived performance. We will be talking next about the responsiveness measurement basics, the frames per second, the profiling charts, and then we will continue talking about the tools for measuring rail. We will mention Chrome DevTools, Lighthouse, Lighthouse extensibility, and web page test. And finally, we will end with the short conclusion. Next slide.
Well, with the expansion of an increase of interactivity, users are beginning to detect longer loading times of web pages and apps more frequently. With this need to increase performance and make pages load faster, Google Chrome developed the Rail model in 2015. Rail is the acronym for Response, Animation, Idle, and Load. This model is a user-centric performance model. In order to optimize a website and performance apps, it was created. So the user interactions are broken down and categorized in these four areas of the Rail model. This model has several applications, but mainly use the measure to measure the performance of the websites and apps and improve the response times, always focusing on improving user interactivity. Rail is a user-centered performance model created by Google, which focuses on the user's experience when loading, tapping, and scrolling in a web page. On the back end, the site is getting all the files and sources, while on the front end, the browser is loading the text and the images the web is going to display. Rails stand for Response, Animation, Idle, and Load, which are the domains used to analyze and improve the performance of a website. This model was created for web designers who want to create user-friendly websites with excellent and fast performance. And after the need to create a model that would enable designers to measure the speed index and or initial load time. The main goal of the Rail model is to offer an excellent user experience by enhancing the response, animation, idle, and load of the web page. Therefore, it is essential to know what each domain refers to. Response. It refers to how fast a web page can respond to a user interaction. When a user clicks on a button, there must be a response, which has to be carried out as quickly as possible before the users notice any delay. Otherwise, the user will start to click again on the same button and the response from the first click must be interrupted. Animation. It is a key domain for apps and web pages nowadays. It goes from scrolling to view transition. Thus, the designer should pay special attention to the time animation takes to react because users interact directly with it and can be noticeable much faster than with any other command. Idle. It refers to what is happening in the background of the web page after the loading is done. Idle provides an opportunity for preloading, prefetching, and pre-connecting resources, and all the things that need to be done before the users interact with the web page don't need to be done quickly as in response or load. Load. It refers to the first meaningful pane of the website with which the user is in contact. This interaction should take less than 1 minute, but it doesn't mean that everything has to be loaded by the time the loading is over. The idea is to provide the user with at least some content instead of showing a blank white screen. Time and perceived performance. In 2015, Googlers Paul Irish and Paul Lewis proposed the RAY model to allow designers to improve their web pages' performance by analyzing the user perception of performance delays. They proposed the following response time scale as listed as follows. From 0 to 16 milliseconds, users perceive animation as smooth so long as 60 new frames are rendered every second. That is 16 milliseconds per frame, including the time it takes for the browser to paint the new frame to the screen, leaving the app about 10 milliseconds to produce the frame. From 0 to 100 milliseconds, response to user actions within this time window and users feel like the result is immediately. Any longer, and the connection between action and reaction is broken. From 100 to 1000 milliseconds, things feel part of a natural and continuous progression of tasks. From 100 milliseconds or more, users lose focus on the task they are performing. From 10,000 milliseconds or more, users are frustrated and are likely to abandon tasks. They may or may not come back later. Responsiveness measurement basics. Measuring responsiveness is not the same as measuring loading, as the first one involves user interaction and differs in terms of hardware, web engineers, and screen sizes. There can be measurement of feedback delay, time after an interaction, frame rate when scrolling and animating something, and networking time for on-demand resources. On the other hand, there are some negative connotations that can affect responsiveness of the website and which cannot be handled easily. These are video acceleration and GPU memory, CPUs, cores and clock, JavaScript runtime, and RAM. However, it is said that there are some tricks that can be used to overcome this inconvenience and improve responsiveness. Frames per second. Some browsers enable frames per second counters to allocate on their device screen, which are used to optimize the scrolling, the start animation, and interact with the content. The goal is to keep a 60 FPS to prevent users from noticing delays. However, some researchers have stated that a high FPS is not the only important metric, and that, on the contrary, keeping a frame rate consistent is what matters the most. Profiling charts. Profiling refers to the analysis used to measure memory space, the complexity of a program, or the implementation of certain instructions in order to optimize it. Thus, when it comes to profiling graphs, it can be done to analyze CPU and memory usage. In this case, the JavaScript garbage collector can be seen as a problem as it tends to release certain information from memory at inappropriate times that could slow down the performance of the web page and therefore it reduces the time rate.
Okay, I will take it from here. So we will be talking about next about the tools for measuring Rail. We have the Chrome DevTools, the Lighthouse, and the web page test. Next slide, please. The Chrome DevTools. Chrome's built-in developer tools provide an in-depth analysis on everything that happens while your page loads or runs. Chrome DevTools is built directly into the Google Chrome browser, and it can help you edit pages on the fly and diagnose problems quickly, which ultimately helps designers build better websites and much faster. How to measure performance with Google Chrome DevTools. This performance tool is always under development and improvement. According to the Rail principle, although its core functionality remains the same. Through DevTools, we can get performance indicators in many forms such as the summary tab, waterfall, screenshots, page speed insights, app shell pattern, and others. Next slide, please. So here we have an example of a summary tab from Chrome DevTools. The summary tab panel reveals the timings for several categories of activities such as loading, scripting, rendering, painting, system, and idle. The number in the middle of the circle represents how long it took for the web page or app to be fully loaded. This number can suffer some variation based on the internet speed. Another significant value in this is the idle number. Following the Rail model, it is recommended using that idle time to start preloading bits of applications that haven't loaded yet. Next slide, please. The Lighthouse. Lighthouse is an open-source, automated tool for improving the quality of web pages. You can run it against any page, public or requiring authentication. It has audits for performance, accessibility, progressive web apps, SEO, and more. It is possible to run Lighthouse in Chrome DevTools from the command line or as the node module. You give Lighthouse a URL to audit, it runs a series of audits against the page, and then it generates a report on how well the page did. We can see that example in Figure 2. Next slide, please. And now we will talk about the Lighthouse extensibility, which is divided in two parts, the stack packs and the Lighthouse plugins. The stack packs, it allows Lighthouse to discover which platform your site is built on and display specific stack-based recommendations. These recommendations are determined and administered by experts from the community. The Lighthouse plugins, it allows domain experts in the community to broaden the viability of the Lighthouse for their particular needs. At this point, you are able now to leverage data that Lighthouse collects to create new audits. Essentially, a Lighthouse plugin is a node module that implements a set of checks that will be run by the Lighthouse and added to the report as a new category. Next slide, please. The web page test. Web page test is the world's leading web performance tool. The main goal of this test is to audit the speed of web pages and apps. It is a tool that can be run from anywhere without requiring any installation, only needing a browser to run. This measuring tool covers a wide range of performance metrics. This tool is often used by performance analysis teams because it can easily save and share information. This is possible because web page test is a tool where the results are not deleted. It allows all the results to be analyzed and performance problems in websites and browsers to be reviewed. Next slide, please. So here we have a web page test performance result, an example. In summary, Although there are several performance tools available, Web Page Test has proven to be one of the most complete and able to measure and evaluate web pages in the best way in different scenarios such as general testing, historical testing, comprehensive testing, location testing, and advanced use. Figure 5 shows an example of what an output obtained using this performance measurement tool would look like. Next slide, please. And finally, concluding, we can perceive that the Rail module was designed to achieve excellent performance of websites with quick loading time. It focuses on the overall user experience, providing developers a reliable benchmark in order to measure and upgrade website efficiency. In terms of performance, the Rail module fulfills the user's needs. As we could see throughout the slides, the model has various ways of measuring users' interactions. It also considers various contexts of user interaction on the website instead of targeting a single performance metric. For instance, when something is loaded, clicked, or scrolled. Although we can verify that each of these panoramas aims for different performance goals, the user expectation may vary from context to context. Next slide, please. Thank you for your attention. And I hope you liked our presentation. Thank you. Here are the references that we used.